Hi, guys. Welcome back to Chemistry with Miss Hernandez. We're working with fifth period class. Today is Monday, November the 2nd. We're working on section 6.27, except we're today working on pair deck. Okay, it's the same information, it's just on pair deck. Okay. 6.21, periodic trends and electronegativity, working with fifth period, and Alexia has already volunteered to read our introduction for today. Go ahead, ma'am. Is it easy or hard for you to make new friends?
Have you ever noticed how some people attract others to them, whether it is their personality, attractiveness, or athletic skills? Something pulls people toward them, while others have a smaller group of friends and acquaintances. Atoms do the same thing. One atom may pull electrons strongly to it, while a second type of atom has much less pulling power.
All right. Thank you, Alexia. So, if everybody knows that popular kid in school, right? Whether it's the head of the cheer squad, the head of the football squad, maybe the quarterback. It could also be maybe one of the band members or even the mariachis. But either way, all of them have a special skill. They easily make friends, right? They easily can pull people without even trying into their circle, right? Um, and it might not be because they're the best player or the best band player or the best cheerleader, but it just may be that something about them makes people happy. Okay. And in every group, it doesn't have to be the popular group. It could be any group, it could be my group of friends. It could be Melissa's group of friends. Every group of friends has that one person that everybody runs to because they're the best listener. They're the best people, advice person. They're just really good people all around. Okay. And so atoms work the same way. There are certain elements on the periodic table that have a very strong pull when it comes to electrons, attracting electrons anytime there's a bond, that they form a bond. So if I'm an element, I'm another element, there's something that connects us, right? And that connection is electrons. And these electrons, well, they can move closer to one element or the other, depending on how strong they are, right? Sometimes the electrons will be closer to this element, sometimes the electrons will be closer to this element. It just depends on how strong it is, okay? Now, electronegativity. Electronegativity, valence electrons from both atoms are always involved when those two atoms come together to form a chemical bond. Uh, Chemical bonds are the basis for how elements combine with one another to form compounds. When these chemical bonds form, atoms of some elements have a greater ability to attract the valence electrons involved in the bond than other electrons. And here you have a really good picture, right? You have this atom, this blue atom, that's magnetically pulling these other atoms into it. Okay, and we don't know if they're atoms, we don't know if they're electrons. Either way, we know that they are being pulled into by that blue atom. And it even says, "Ooh, I'm falling for him." Ooh, he's so strong, right? Well, that's what those atoms are thinking, or those electrons, and they're getting drawn closer and closer to him. Except there is no actual magnet. It's just the atom itself bringing those other atoms in, or those electrons. Now, if you probably have asked yourself, what is electronegativity? Electronegativity measures the ability of an atom to attract electrons. Okay, when an atom is part of a compound. So if you have a bond, right? If you have a bond between two elements, there's going to be valence electrons that are being shared or transferred, or and if you have two electrons or two atoms, and in this case, let's say that this is chlorine and this is sodium. Well, there's going to be some electrons, and I probably shouldn't have connected them. So if I have sodium and chlorine, well, we have two electrons that are in here in between. Now, depending on how strong the atom is, that will bring in these electrons a little bit closer to one element than the other. Okay, we call this electronegativity. Okay, that just means these guys are in a bond, these two elements, and the electrons that they have in between them are a lot closer to one element than it is to the other. Okay? So think of that when you are thinking of electronegativity. I always like to think of it as a tug of war, right? If you are, right, there's always a rope with a knot in the middle, and whoever gets the knot across wins the tug of war. Well, in this case, instead of having a knot, we have two electrons, right? And one element pulls, and then the other element pulls, and then they go back and forth until somebody wins the war, right? That's what tug of war is. Electronegativity is different from electron affinity because electron affinity is the actual energy that's being released when an atom gains an electron. Electronegativity is not measured in units of energy, but rather a relative scale. All elements are compared to one another, with the most electronegative, fluorine, being assigned an electronegativity value of 3.8, which is 4.0. That's the strongest that anybody can have for electronegativity. Fluorine attracts electrons better than any other element. The table below shows the electronegativity values for these elements. So if we were to open up, and I'm just going to do a Jamboard really, really quick, and I just want to draw a picture, and it shouldn't take me long. All right, so let's say you have fluorine, and then you have another element like hydrogen. Okay, so remember, there is a tug of war for these electrons. Now, we know right now that fluorine is the strongest when it comes to these electronegativity. So when it comes to the bond that these guys form, these electrons are going to be way closer to fluorine than to hydrogen. Why? Because fluorine is really, really strong. Yes, these electrons are still rotating around both, but they're going to be a lot more closer to that fluorine than it will be to that hydrogen. Okay, it's still going to be rotating around, but the electrons that are here will be a lot closer to fluorine than to hydrogen. Okay, that's what we mean. I always like to say that fluorine is like Dwayne the Rock Johnson, right? He's really, really strong, especially in the movies, right? Everybody, when they go against him, they never beat him because he is so strong. The same thing happens for fluorine. When it comes to sharing those electrons, fluorine always takes over. Okay? Fluorine already always takes over. All right, you have your first question, guys. True or false? You are to pick true or false. Electronegativity is a measure of how easily an atom attracts a pair of electrons to form a chemical bond. True or false? Is electronegativity measuring how easily an atom attracts a pair of electrons to form a chemical bond? What do you think? Is that a true statement or a false statement? And if you're not in the pair deck, you should be answering in the chat. I got 7 people in here. Only 2 have answered. I need at least 5 answers, guys, before I start showing the answer, the correct answer, or discussing the correct one. 5 people have answered. Good job. And 5 out of 6 have said that is a true statement. Okay. All right. Now let's go here to the presentation. And it says here electronegativity measures the ability of an atom to attract electrons in a bond. Very good. That is a true statement. Good job, guys. Now let's talk about what happens to metals versus nonmetals and electronegativity. Okay, always think what group is closer to fluorine, metals or nonmetals? Metals or nonmetals? Whoever's closest, I'm always gonna think, okay, fluorine is the strong guy. So that means that all the nonmetals that are close to it will also be strong. That's what I would think. Since metals, and we're talking about everybody on the left side, right? And I'm talking in terms of right here in purple, in yellow, in orange, and in red. All of those are metals. Since metals have few valence electrons, they tend to increase stability by losing electrons to become cations, right? You lose electrons, you become a cation. So, consequently, electronegativity of metals are considered to be generally low. Okay? Since they lose electrons a lot, like 95% of the time, electronegativity is considered to be low because they have a tendency to let go of those electrons. Okay? Now, nonmetals. Nonmetals will have more valence electrons, increase their stability by gaining electrons to become anions. So their electronegativity is considered generally high. Okay? The closer and closer you become to fluorine, the higher your electronegativity is. And we know that all this group right here in green are all nonmetals. All of this group right here will have a very high electronegativity. A very high electronegativity. Very good. Now, let's talk about trends and pay attention because the question they ask you is going to do a lot with this trend. Electronegativities generally increase from left to right. Okay, that makes sense, right? If I'm going from the alkaline metals and I'm getting closer and closer to fluorine, I should get stronger. So the fact that it says that it increases, I agree with that statement. Yes, it does increase. And if I go down a group, well, I'm getting bigger and bigger and bigger. So that means I'm getting further and further away from the nucleus, making it easier to lose electrons. So when it comes to electronegativity, it will decrease as you go down, okay? It becomes weaker and weaker and weaker the bigger you become as an atom, okay? Alkali metals. Okay, so it says that it increases from left to right because of the nuclear charge. That nucleus is getting stronger and stronger and stronger. Alkali metals have the lowest electronegativity, right? Alkali metals, group 1 in red, right here, all have low electronegativities. They usually give up electrons. While halogens have the highest, group 17. Group 17 is where you find fluorine, okay? They have the highest electronegativity. Because noble gases do not form compounds, they do not have electronegativity. So you'll notice right here, group 18, group 18 in blue doesn't participate in electronegativity because they don't need they don't need a bond with any other element to get that 8 valence electrons. They already have it. So are they going to want to bond and give up and transfer? No, they're not going to be doing that. Note that there is a little variation among the transition metals. Electronegativities generally decrease from the top within a group to the bottom due to large atomic size. So as you go down a group, it's going to get weaker and weaker and weaker. Why? Because you're getting bigger and bigger and bigger as an atom. You're getting further and further away from that nucleus, making it easier to lose electrons. Okay? Now you're going to draw. You're going to draw a red and a blue arrow. The red arrow will show electronegativity increasing, getting bigger and bigger and bigger. You will have a blue arrow that will represent electronegativity decreasing. Okay, so you're either going to put it left to right, left or right, up or down. It just depends on what you remember. Has anybody answered? Has anybody drawn their arrows? No. Come on, Mario, Melissa, get in there and draw your arrows. What do you think? What direction does electronegativity increase and what direction does electronegativity decrease? Two people have responded. Oh my God, I'm so sorry. Three people have responded. Anybody else gonna try it out? Is anybody else going to try this out, please? Anybody else? I only have three people who have responded. Take a guess, guys. If you don't know the answer, take a guess, okay? Sorry, I went to get my water. All right, let's look at what their responses is. Let's see who is paying attention. Ooh, this is a good one. It says it's increasing to the right and it's decreasing down. Good one. This one says they're both going up. Electronegativity decreases up and it increases up. That one does not make sense. Okay, Oscar, it says that he was number one. This one didn't draw. And this one deleted the response. Guys, don't be afraid to be wrong. A lot of people are wrong. Good job, whoever did this one. If it was Oscar, good job. Good job, Oscar. All right, now you have some time to think. Let's put our little thinking cap on. And you have some options. Indicate or circle or identify the element with the largest electronegativity in the group of the halogens. What halogen, group 17, over here, group 17, right here, fluorine, chlorine, bromine, and iodine, has the largest electronegativity value? Pick an answer. And I got one person who's responded. Okay, and I'm going to give you a hint. What element is closest to fluorine? Okay, if you're trying to figure out who has the largest, electronegativity, you need to find an element. Oh, and I already kind of gave the answer out. That was the wrong one that I was supposed to. Okay, it's okay. All right, so I got fluorine, one person chlorine. Guys, when it comes to electronegativity, it's all about fluorine, okay? Fluorine always, always is the strongest, okay? All right, bond type. There are different types of bonds that form depending on electronegativity. If you take your numbers, your electronegativity, let's say you have hydrogen and fluorine. It said for hydrogen, I have here. For fluorine, we know it's 3.98. Okay, and that's not a G, it's a decimal. Okay, for hydrogen, if you look at the pair deck, 2.20, 2.20, I believe. So you got here 2.20. If you're trying to figure out the bond type, there are 3 types of bonds. All you have to do is you're going to take 3.98 and subtract 2.2. Whatever you get here, I think this was 1.78. If you get an answer that's above 1.7, that is considered an ionic bond. If you have between, I think it's like 0.5 to 1.7, you have what's known as a polar covalent bond. If you have anywhere below 0.5, it's considered a non-polar covalent. So non-polar just means that those electrons are stuck in the middle, straight in the middle. If it's polar covalent, that just means that it's closer to one element than the other. If it's ionic, that means that electrons are transferred to the nonmetal and all the electrons are closer to that. Okay? Okay, so here you have fluorine has the highest electronegativity. Cesium has the lowest, 0.75. This indicates that fluorine has a high tendency to gain electrons from other elements with lower electronegativity. We can use these values to predict what happens when certain elements combine. The following video shows this, okay? Let's watch the video.
An atom attempts to attract electrons toward itself when bonding with another atom. The level of attraction of each atom is called its electronegativity. When sodium and chlorine react, the chlorine atom removes sodium's valence electron and becomes a chloride ion. The less electronegative sodium atom cannot compete for electrons and becomes a sodium ion. The attraction between the ions is an ionic bond. When bonding atoms have nearly equal electronegativities, neither can attract electrons away from the other. In a carbon-sulfur bond, the electron pair is shared almost equally between the two atoms, resulting in a covalent bond. When hydrogen and oxygen react, the more electronegative oxygen atom cannot completely remove an electron from hydrogen. The shared electrons are attracted more to the oxygen than to the hydrogen atom. This unequal sharing is called a polar covalent bond. Polar bonds have a slightly negative and a slightly positive end.
All right, so let's go back. If we talk about the example number 1, right now we know chlorine is a lot stronger than sodium. This electron is going to get transferred to chlorine. They'll still be shared, and you'll see it rotating around both, but it's going to be mostly rotating around chlorine. That's an ionic bond. There's been a transfer of electrons. The second example is carbon and sulfur. Look at that. They have the same strength. So the electrons that are going to be shared are going to be shared evenly between both.
When bonding atoms,
okay, they're going to be shared equally between both. If you're talking about the third type, polar covalent, look at how much stronger oxygen is compared to hydrogen. So yes, they're still sharing electrons, but most of the time, that electron is over here with oxygen. It will every now and then go back to hydrogen, but for the most part, They are living with hydrogen. Okay?
Is called.
All right. And now this is the one that I thought we were doing earlier. Which has a greater electronegativity? And I believe they give you carbon and nitrogen as your option. What I always like to think of is who's closer to fluorine? What element is closer to fluorine? Carbon or nitrogen? Okay, and I believe those are your answers. Nitrogen or carbon? What do you guys say? Is nitrogen closer to fluorine? If it is, that will be the element that is stronger between the two. All right, I got 2 people who have responded. Both of them said nitrogen, one person said carbon. Look at what you see here. If you see fluorine all the way over here with 3.98, who's going to end up closer, carbon or nitrogen? Very good. Nitrogen is correct. All right, let's summarize today's topic. Electronegativity measures the ability of an atom to attract electrons when it is part of a compound or a bond. Electronegativity value increase generally from left to right. Electronegativities generally decrease from top to bottom. And the element with the highest electronegativity value is fluorine. You have 4 questions that you're going to do. We're going to skip number 2. It says define electronegativity. Why are the electronegativity values of metals generally low? Number 3, describe the trend in electronegativity across the periodic table. And then describe the trend of electronegativity in a group of the periodic table. Okay, so we're going to work on those 4 questions. We're skipping number 2. And we're going to actually work on them here. In here. Skip number 2. That's why it's highlighted. Okay, I think I got everybody for attendance purposes. All right, let's start it out. We got 9 minutes. Let's get it done. Number 1, define electronegativity. Define electronegativity. And that answer is actually right here in the summary, and I'm not even going to move it. I'm just going to leave it there.
Electronegativity is a measure